Hello everyone and salutations. I am from HP1 Group 3 and today I will present about machine learning. Firstly, let me introduce myself. My name is Muhammad Aliff Danial bin Muhammad Azman and are my colleagues that will help me present with my topic today. So, an introduction to machine learning. Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve their performance without being explicitly programmed. Instead of following fixed instructions, machine learning algorithms analyze patterns in data to make predictions, decisions, or classifications. The field is generally divided into four main types: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning, each with different approaches to solving problems. The first one, supervised learning. Supervised learning is the most commonly used type of machine learning. In this approach, the algorithm is trained on a labeled dataset, meaning that each data point comes with both input features and the correct output. The system's task is to learn the relationship between the inputs and outputs so that it can accurately predict outcomes for new unseen data. The second one, unsupervised learning. Unsupervised learning is fundamentally different from supervised learning because it works with unlabeled data. The system does not know the correct answers in advance. Instead, it must explore the structure of the data and identify hidden patterns or groupings. This makes unsupervised learning especially useful for discovery and exploration of labeled data that is not available.
So now we move on to the applications of machine learning. Machine learning is one of the most significant advancements in the field of technology. It gives machines the ability to learn from data and improve over time without being explicitly programmed. Machine learning models identify patterns from data and use them to make predictions or decisions. Many organizations use this machine learning to automate tasks, make smarter decisions, and gain valuable insights. So the parts of machine learning, we can divide it into three parts, which is healthcare and medicines, transportation and mobility, and also internet and technology. For healthcare and medicines, I will give you the example of disease diagnosis and personalized treatment. For disease diagnosis, we can use machine learning to detecting cancer, diabetes, or heart problems from scan and tests. We use this medical images like X-ray, CT scans, MRIs, and many more to help us. It is also can reduces human error and supports doctor, not replacing them, but assisting them. So for the personalized treatment, machine learning also help us to predicting what treatment works best for each patient. This also helps by analyzing all this information to recommend the most effective treatment. This also can lead to the speeds up recovery and improve survival rates. For the transportation and mobility, machine learning has also provided self-driving cars. A self-driving car, also called as an autonomous vehicle, uses machine learning to see, understand, and decide what to do on the road, just like a human driver, but automatically. A modern autonomous car is packed with sensors such as cameras, radar, LiDAR, and ultrasonic devices that constantly collect information about the environment. The system then determines the car exact position on the map and predicts how nearby objects are likely to move. And also machine learning is central because it allows the car to improve over time by learning from millions of miles of driving data, making autonomous driving is safer and more reliable for us.
Hello, my name is Muhammad Ammar Najmi and I will talk about how to do machine learning. First step is understand the problem. Without a clear objective, even the most powerful algorithm cannot help. Example of problem, predicting house prices based on size, location, and number of rooms. The next step is collect data. Without good data, the model cannot learn effectively. Taking the past example, to predict house prices, you need a data set of houses with details such as square, footage, number of bedroom, location, and selling price. The next step is prepare the data. Raw data is often messy, incomplete, or inconsistent. Before feeding it into a model, it must be cleaned and organized. There are steps in data preparation. First, handle missing value by filling, removing, or estimating them. Second, remove duplicate and fix error. And lastly, split the data set into training set to teach the model and testing set to check how well the model works on new data. The fourth step is choose a model. The model is the mathematical system that learns patterns from data. Choosing the right model depends on the type of problem. There are three of models, and no single model works for all problems. Sometimes you need to try several models. Is train the model. Training is the process of teaching the model. Taking the past example, in predicting house prices, the model learned how much each factor, size, location contribute to final price. The goal of training is to minimize error. The next step is evaluate the model. After training, the model must be tested on new unseen data to check how well it performed. Evaluation metrics include accuracy, precision and recall, mean square error. If performance is poor, the model may be underfitting or overfitting. Next step is improve the model. If the model is not accurate enough, improvement can be made by hyperparameter tuning, future engineering, trying different algorithms, and adding more data. And for the last step is deploy the model. Once the model is trained and accurate, it can be deployed in real-world use. Deployment often includes continuous monitoring and updating so that the model improves with new data.